Hello, and welcome to today's lesson where we are going to investigate the relationship between proportions of side lengths or any other length of a shape and the proportion of the areas of the shapes. Okay, we've got a nice relationship between those two that help us set up and solve a lot of situations. So let's look at some of our values here. Okay, how can we find out and see what is the proportion of the side lengths? So when we're looking at our side length proportions, we've got 3 to 6, we've got 5 to 10. Okay, we can simplify it down and we can see that both of these are 1 to 2 side length ratios. Now, if we find the areas of these two shapes, 3 times 5 is 15. So our area, 3 times 5 is 15. We look at our next shape. The area is 6 times 10, or 60. So we can see 15 to 60, it is not a 1 to 2 relationship. When we are looking at the areas, we've got a 15 to 60, okay, making sure that we're going small to big in this situation. Simplifying it down, it's 1 to 4, not 1 to 2. And what we want to do is we want to think about and answer this question here at the bottom. Okay, how is the ratio of the sides related to the ratio of the areas? And what we want to think about is how many dimensions we're working with. Okay, when we talk about a length is one dimension. Okay, when we talk about area is a two-dimensional measurement. Okay, so when we think about our units, our length on any of these values, if we go back and we call it centimeters, a length is 3 centimeters. Okay, notice that there is no exponent here. Our area, if we're dealing with a value, is 15 centimeters squared. Okay, that squared tells us we're dealing with two dimensions, length and width. So if we want to make the relationship between a side length ratio, okay, our side length ratio in this situation was 1/2, or for every 1 unit in the first shape, we've got 2 units in the second. What we have to do is take that 1/2 and square it for our two-dimensional shape, because we've got 2 lengths, a 1/2 for the length, a 1/2 for the width. So we have to square that 1/2 to get our ratio of 1/4. And then we can end up using that ratio to solve problems. Okay, so now looking at this one, what's the ratio of the radii, smaller to larger, of these two circles? Okay, so we've got a small radii of 4, large radii of 8. We can simplify that down to a 1/2 ratio, and that is for the radii. And if we want to turn that into an area ratio, remember, radii is a one-dimensional measurement. Area is a two-dimensional measurement, so we take that ratio and square it, and that gives us the ratio of the areas, okay, 1 to 4. So now, proportional areas conjecture. If the corresponding sides of two similar polygons or the radii of two circles compare in the ratio of m over n, then their areas compare in the ratio of m over n squared or m squared over n squared. Okay, so we usually don't leave it in this form. We want to get it to its most simplest form, when we are listing an answer for a problem. Okay, so now let's start using this situation. We're told that the two triangles are similar. So now we know that we have a side length ratio of 6 to 9. Okay, we can simplify that side length ratio down to 2 to 3. Okay, so that's our sides ratio. And now I need an area ratio where I'm going to take this 2 to 3 and square it. So my area ratio is 4 to 9. Okay, so now once I have the area, small to big, now I can set up my proportions. You know, everything we've been doing in this semester is really proportionally based. So 4 is the small, 9 is the big. So my 54 has to go with the 9. My x has to go with the 4, making sure I'm getting the values lined up properly. So here is my area ratio, and here is the actual areas. And then I can cross multiply and solve from there. So I've got 9x equals 54 times 4, or 216. Divide both sides by 9, and I get x equals 24 centimeters squared. Okay, always remember your units. Okay, in the Schoology quizzes, we have the units there for you, but you always want to think about the units of your answers. Okay, so what we want to remember is our basic fact, and we're not going to finish all of this until we finish our next lesson, but when sides are ratio m over n, the area is m over n squared, or m squared over n squared. Okay, so you can see how we can work backwards if we want. If we square root our area ratio, we can get a side length ratio. And then in the next lesson, we'll talk about the volume ratio when we look at that piece. Okay, so now, once again, just using our process, working through these problems, we're told that the figures are similar. We've got our 6 to 9 side length. So in this situation, once again, when we're dealing with the sides, okay, we've got our 6 to 9 side length. The ratio can be simplified down to a 2 to 3. Then I need to convert it to an area ratio. So I'm squaring the 2 to 3 to get a 4 to 9. Okay, once I have my area ratio, okay, I'm told that CAT, C-A-T, which is the small triangle, it's not the large triangle, so I'm making sure that I am setting this up properly. 4 over 9 equals small 42 over x. And then I can cross multiply and solve. 4x equals 42 times 9, 378. Divide both sides by 4, and I get 94.5. And then we tack our units on, centimeters squared. Okay, so now, just a couple last pieces here as we're finishing up here. The ratios of the lengths of the corresponding hypotenuses for two similar right triangles is 2 to 7. What is the ratio of the areas? So remember, sides are always power of 1. And if I want to convert it to areas, I need to take that ratio and do the power of 2, or squaring those values to get a 4 to 49 ratio. Okay, there's a number of ways that we can write it. Okay, so just make sure you're using proper notation in lowest terms for that. We can't divide 4 and 49 by any value, so they are in the lowest terms. Okay, now this last one is a chance for us to work backwards. So what we want to remember here in this last example is we're given the area ratio of 16 over 25, and we need to turn it into a side length ratio. Okay, so remember, area is a squared measurement. Side length is a measurement to power of 1. So what we need to do is we need to square root the area measurement to turn it into a side length measurement. Square root of 16 is 4. Square root of 25 is 5. So we have our ratio of the side lengths of 4 to 5, and then we can use that ratio to find any measurements that we're looking for. Okay, so remember, your main idea for today is the idea of converting from a side length ratio, which has a power of 1, to an area ratio that has a power of 2, or a squared value. And then we can also work backwards. We can turn an area ratio by square rooting the values into a side length ratio to finish up. Okay, that is the end of our lesson for today. Have a good day.